7.4 is on page 366, talks about inverse Laplace transform. So assume that the inverse Laplace transform of those three functions exist and are continuous on the interval from 0 to infinity. Let's say be a constant. If you take the Laplace on the sum of two functions, that will be the sum of the inverse Laplace of the functions. If you take in the inverse Laplace of a constant times a function, you ignore the constant, take the inverse Laplace of the function, multiply it by the constant. So determine the inverse Laplace transform of the function. Here what we're doing, we're looking at wrong form. Here we go. We're looking at this table, and now we're going backwards. So going backwards, again, you're going to number those for me. So when I look at section 7.4, if I apply the inverse Laplace transform, that would be, if I look at the formula sheet, 2 divided by s squared plus 4. So 2 divided by s squared plus 4, since it's a number, we're talking about number 5. That's going to be the sign, and what's taken the place of a is 2. So we look at the sign of twice t, and you're going to have to tell me that you used property number 5. And if I apply the inverse Laplace transform on number 4, that's going to be the same, but I need a 3 there, so I could put a 3 there and divide by 3 before I start. And let me use the red color. I'm going to multiply this by 3 because I need that to match, and multiply by a third. So when I apply the Laplace inverse transform on that, the 4/3 I drag up front, and again it's the sign of 3t, and that is by property 5 again. Put that on top of the equal. And if I apply the Laplace on the following, the inverse Laplace transform on this, well, if I look at this, I notice this is matching okay, right there. It's matching number 9. Number 9, whatever n plus 1 is, this has to match. So I need, if I look at the denominator, the top is 1 power less than that. So if this is 3, I need a 2 there. 2 factorial really, but that's fine. So I divide 2 factorial is 2. So this 3/2, I'm going to really apply the inverse Laplace transform on this. The 3/2 moves up front, and that's going to be t raised to that power e to the -5/2t. And that is, again, on top of the equal, that is by the 9th property. If I apply the inverse Laplace transform on number 8, s to the 5th, let's see what that is. 1/s to the 5th. So we're talking about number 3, but I need 4 factorial at the top. So if this is 5, I need 4 factorial. I'm going to multiply by 4 factorial and divide by 4 factorial. Let me make that better. Here we go. So I'm going to multiply this by 4 factorial, divide by 4 factorial. When I apply the inverse Laplace transform on this, that's 1/4 factorial times t to the 4th, and that is by 3. It was 3, right? Yeah. So that's how this really is played. Now if I want to apply the Laplace transform on number 10, well, we have a problem that's not matching. So what I do, I go on the side and I say, alright, well, if we take 2 into s squared plus s over 2. To complete the square, I need to take half of this number. Half of this number is 1/4 and square it. So if I add, there's a 6 there, I subtract 2 times 1 over 16 because I added this number in. I need to subtract it to make sure that this is balanced. So this is twice s plus the number before I squared it squared, and this is over 8. So all over 8, 68. That means 48 minus 1 is 47. So now I need, for this to work, I need this to be s plus 1/4. That is s plus 1/4 minus 1 minus 1/4, that's 5/4, divided by 2 times s plus 1/4 squared plus 47 over 8. So I could say this is pretty much taking 1/2 out of this, s plus 1/4 over s plus 1/4 squared plus 47 over 4 minus 5 over 4 over s plus 1 over 4 squared plus 47 over 4. The numbers are not pretty, but so what? And now for this to work, I know when I apply the Laplace, I'm going to get e raised to the negative 1/4, but here I need the square root of that at the top, because it's a over s squared plus a squared, and if I apply the inverse Laplace transform on this, that is going to come out to be 1/2, because that's a constant, e to the negative 1/4 t, and s, so that takes care of the shift. That becomes s over, so the cosine of the square root of 47 over 2 minus 5/4 e to the negative t over 4th, or 1/4 t, the sine of square root of 47 over 2t. And we know this one is right here is, let's see, which one is that? The shifting with the e, that's by 8 and 7. This is by 8, and this is by 7. The next set of problems, so if I can't find the partial fraction decomposition, I'm going to say this must be a over s minus 1 plus b over s plus 3. So if I clear the fractions, s plus 11 equals a times s plus 3 plus b times s minus 1. And the shortcut, let s equal 1. 1 plus 3 is 12. 1 plus 3 is 4. And that's a 0, so a is 3. And if I let s equal negative 3, then negative 3 plus 11 is 8, that's a 0. And a negative 3 in there, that will make it b times negative 4, so b is negative 2. So this is nothing more than 3 divided by s minus 1 minus 2 divided by s plus 3. And now, if I apply the Laplace inverse transform on this, that's really the inverse Laplace transform on this. This will give me f of t. That will give me 3e to the t minus 2e to the negative 3t. And again, I'm going to have to quote where this came from. The exponential really comes from 4. So 4 for both of those. And that's really how we play those out. So partial fraction decomposition, something you learned in second semester calculus. Of course, you learned that in algebra too, but second semester calculus when you did the partial fraction decomposition of integration or integral of rational functions. So 24 is next. This is a bit tougher. This is going to be a over s minus 1 plus bs plus c over s squared minus 4s plus 13. So if I play this, I'll get 7s squared minus 41s plus 84 equaling a times s squared minus 4s plus 13 plus s minus 1 multiplied by bs plus c. Let s equal 1. I'll get 7 minus 41 plus 84 equaling a times 1 minus 4 plus 13, and that's a 0. So I will get, let's see what that is, 91 minus 41 is 50, and this is 13, 40, that's a 10. So a is 5. Now I could use the book's method, or I could choose two other values of s. Let s equal 0. 84 equal 5 times 13 plus a negative 1 times c. So this is 5 times 13 is 65. 84 minus 65 is 19, I think. 19, 67, 84. So c is negative 19. And to find b, I could let s be anything other than 0 or 1. Let's choose negative 1. So that is 7 plus 41 plus 84 equaling 5 into 1 plus 4 plus 13 plus negative 2 times b times negative 1 negative s plus c, but I know c is 19, negative 19 I meant. So if I work this out, I'm looking at 80, 120, 130, 4, 120, 127, 128, 132 equal 5 times 18 plus 2s plus 38. So altogether I'm looking at 132 equal, this is 5 to 90 plus 38. That is 90 plus 130, 128 plus 2s. So I could say 10 equal 2, so s equal, that's not 128, 128, that's a 4. So s equal 2. So pretty much this is what I got. I'm going to shrink this a bit. So I'm able to get this to be a 2. So I could say that this is 5 over s minus 1 plus 2s minus 19. At the bottom I need to complete the square on. That is s squared minus 4s. Take half of the middle number, which is 2, and square it. If I take 4 out of that, that's a 9. So the denominator is s minus 2 squared plus 9. So I need 2s minus 19. I'm going to take 2 into s minus 2 to match. That's 2s minus 4. minus 19, and there'll be a minus 15. So I'm going to split that up. And just like we did the previous one, I need to multiply this by 3 and divide by 3. And if I apply the inverse Laplace transform on this, that's really the inverse Laplace transform on this. This will give me f of t, which is the solution, 5e to the t plus twice e to the 2t, and this was s, that's a cosine of 3t. We just did that on the previous problem. This is 8, this is 4, and here this is going to be minus 5, because 15 over 3 is 5, e to the 2t sine of 3t, and that's believed to be is 7, and there's the answer. So kind of hectic, but you'll show all of this work. And if I get to this problem, the same issue happens. This is a bit lengthy. Well, let's see how this works. This is going to be a over s plus b over s squared plus c over s cubed plus d over s minus 2. If I clear the fractions, 7s cubed minus 2s squared minus 3s plus 6 equal as squared times s minus 2 plus bs times s minus 2 plus c into s minus 2 plus ds cubed. Now if I let s equal 0, I get 6 equal 0 plus 0 plus c times negative 2 plus 0. So c equal negative 3. If I let s equal 2, I'll get 7 times 8, which is 56. Let me see. I worked this out. I'll make sure the numbers match. I'll get 56 minus 8 minus 6 plus 6 equal 8. Oh, equals 0. So if you put a 2 there, that's going to be a 0, that's a 0, that's a 0. I'll get s cubed 2, 8, 80. So here, I figure out that, you know what, these two cancel out. That is 48 equal 8d. That means d equal 6. Now I could choose any two values that I like. I could say that s equal negative 1, for example. I'll get negative 7 minus 2 plus 3 plus 6 equal negative 3a. If you put a negative 1 there, negative 1 there, it's going to be negative times a negative plus 3b. And negative 1 in there, that's plus 9 minus 6. So here, I would say that is 9 minus 9, that's 0 equal negative 3a plus 3b plus 3, or simply I could say negative a plus 3b equal a negative 1. And if I let s equal, let me see, 1, I'll get 7 minus 2 plus 3 plus 6 equal negative 3a plus 3b plus 9 minus 6. Oh, I'm sorry, I messed up. 1. That's negative a minus b plus 3 plus 6. So here I'll get 5. 5 plus 9 is, let me see, oh, that's a minus 3. I messed up on that one. So that is negative 5, 1, that is 8 equal negative a minus b plus 9. So if I move those to the left, this to the right, I'll get a plus b equal 1. And if I solve those, I'll get 4b equal, let me make sure, this to the left, this to the right, negative a plus b equal a 1. And if I add those, that should be a 1. That indicates that I forgot what it was before. So this will be negative a, okay, and this will be a minus b equal a 1. So here I'll get negative 2b to equal 0. B is 0. And if b is 0 and I put that in there, I'll get a to be a 1. So all of this work, I get b to be a 0 and a to be a 1. So this is 1 over s minus 3 over s cubed plus 6 over s minus 2. If I apply the inverse Laplace transform on both ends, I'll get f of t to be 1 over s will yield a 1 by 1 minus, I'm going to multiply this by 2 factorial, divide by 2 factorial. Remember, there is a 3 sitting there. So that will be 3 over 2 times t squared, that's by 3, plus 6e to the 2t, and that is by 4. And that will be my final answer. So as you see, instead of integrating, we just use the table, which is the equivalent of integration, except there it is. And now if I go to 28, I'm looking at factoring f out, that is s squared plus s minus 6 and I'm looking at f of s equaling s squared plus 4 divided by s into s plus 1, and this is s plus 3s minus 1, s minus 2. And that is a over s, b over s plus 1, c over s plus 3, and d over s minus 2. So s squared plus 4 equal a times s plus 1, s plus 3, s minus 2 plus bs times s plus 3 times s minus 2 plus cs times s minus 2 plus ds s plus 1 and an s plus 3. If I choose s to be 0, negative 1, negative 3, and 2, I'm done. If I choose s equals 0, I'm looking at 4 equal a times 1 times 3 times negative 2. That's a 0, that's a 0, that's a 0. I'll figure out what a is. That is 3 times 2. So a equals 4 over negative 6, which is negative 2/3. And if I let s equal -1, I'm looking at, again, there's the equation 5, 4 plus 1 is 5 equal a 0. This s equal there. B times negative b. 3 minus 1 is 2, and -1, that's -2. That's a 0. And that's a 0. That should be cs times s plus 1. There we go. So this means that b equals a -5/2. S equal -1. Yep. And if I let s equal -3, I'll get -3, 9, 13 equaling a 0, a 0, and a 0. The only piece that would be left would be this, and that would be -3c times -5, if I'm not mistaken. And that would indicate that c equal -13/30. One more to go and I'm done. I'm going to let s equal the last number in the domain, which is a 2. And I'm going to get 2 squared. 4 plus 4 is 8. And that's going to be a 0. Everything with a 2, 0, 0. And the last number is going to be 2d times a 2. S plus 1 is 3. And s plus 3 is a 5. So the 2 divides that 4 times. That indicates that d is 4 divided by 15. So there it is. And once you get the partial fractions, you're set. Because I could say that this f is actually -2/3/s plus b, what was b? Minus 5/2 over s plus 1 minus 3 over s plus 3. We'll get c. What was c? C was -13/30. 5 times 2. Where did 30 come from? -3 and 9. -3. That's a 0. That's a 0. That's a 0. -3c times. Oh, there's one right there. -3 plus is -2. There you go. So that is the 30. That's right. Plus 4/15/s minus 2. And if you apply the Laplace inverse transform, right here. That would be the inverse Laplace transform. That is -2/3 times 1 minus 5/2 times e to the -t minus 13/30 e to the -3t and 4/15 e to the 2t. F of t equals this mess. And that's the solution to this problem. And the last problem. Oh yeah. I would say f of s times s minus 1 equal 2s plus 5 divided by plus 1 squared. So pretty much I'm getting f to equal 2s plus 5 over s minus 1 times s plus 1 squared. So I'm going to say that is a over s minus 1 plus b over s plus 1 plus c over s plus 1 squared. So 2s plus 5 equal a into s plus 1 squared plus b times s minus 1 into s plus 1 plus c times s minus 1. And here, if I let s equal 1 to 7 equal a 1, 2 squared is 4. So a equals 7/4. If I let s equal negative 1, I'll get a 3 equal a 0, and a negative 1 there minus 2c. That means c equal negative 3/2. And if I let s equal any value, let's say 0, I will get 5 to equal 7 over 4 times 1 plus b times negative 1 plus s equals 0, that's a 1, minus 3 over 2, and if I put a negative 0 in there, that's a negative 1. So I'm getting 20 to equal 7 minus 4b, and if you multiply this by 2 top and bottom, plus 6. That's 13. That is 7 equal negative 4b, which indicates negative 7 over 4 equals. So this is a, this is negative 7 over 4 over s minus 1. B, oh, B is 7. A was, I messed up. A was 7 over 4 plus B, which is negative 7/4 over S plus 1 plus C. And now if I apply the inverse Laplace transform on this, I will get f of t to equal, oh, I rushed that a bit. This will yield, oh, here. This is simply f of t, which is the solution, 7 over 4 e to the t plus 7 over 4 e to the negative t. Remember, there's a 2 sitting there. If there's a 2 sitting there, then I need a 2 and divide by 2. So that is 3 over 4 e to the negative t and times t to 1 less than that. And my answers are dependent on this is 4, no, this is 2. No, this is, let me double check. Oh, that's 4. This is none because you picked an extra t. And there's 9. And that's pretty much it for this section.